So I'm Tom, and I've done some stuff with PowerPoint, which probably shouldn't be done with PowerPoint, but hopefully in this lecture you will learn something interesting, and I think you'll probably learn some stuff that is actually useful, as well as a ton of stuff that is not at all useful. And at the beginning, I'm going to just go over some basic PowerPoint programming principles, and then I'll go over some of the stuff like how you can actually make a Turing machine in PowerPoint. Oh, quick question here. How many people have taken 251? So almost everyone. Great. So you all know what a Turing machine is. We did Turing machine. Oh, you did. Excellent. Great. And then after that, I'll go over some like random stuff you can do in PowerPoint that isn't necessarily related to PowerPoint programming, but demonstrates the principles of doing things that you shouldn't necessarily do in PowerPoint. Cool. So your first question might be like, why would you even try doing programming in PowerPoint? And for me, I had two reasons for doing programming in PowerPoint. So the first reason was that I got into this in 4th grade, and I was working on a computer that was running Windows XP, and only had a very limited set of programs. So it had like Microsoft Office Suite, and then like Paint and Notepad. And if you're trying to do some type of programming, you can't really program it in Notepad or Paint, so you have to use like PowerPoint or Excel. And PowerPoint was my program of choice. The other reason is that PowerPoint actually has a ton of features, and whenever you have a lot of features, they can interact with each other in different ways, and that gives you a lot of edge cases. And those edge cases often have very interesting behaviors in PowerPoint, unlike in most software, where if you have an edge case, you just like make sure that the user can't do it. In PowerPoint, often something very interesting happens. So that means there are a lot of accidental features, and that is very useful for PowerPoint programming. Now, before we talk about PowerPoint programming, we do have to acknowledge the fact that there is some stigma associated with PowerPoint. Apparently, there was some study which said that PowerPoint is worse than useless for presentations. Actually, makes presentations worse. Which just shows that if you have the software on your computer and you're not going to use it for presentations, then you should be using it for something else, namely PowerPoint programming. All right, so also there's some very bad PowerPoint presentations. So because PowerPoint has so many features, you can combine them in very awful ways. So do not put text on top of images, and do not use ridiculous animations, and all kinds of random word art stuff. All right, anyway, so now we're going to get into the actual programming part. So the first thing you want to do is set up your PowerPoint IDE, which is easier than Vim, which I think says something about Vim. So the first thing that you want to do is you want to notice that PowerPoint has a quick access toolbar at the top. So this is going to be very important for PowerPoint programming because there are a lot of features that you want to access quickly. And you can just take any action, you can right click on it, and you can add it to the toolbar. So like if I want to add this layout thing, I can just add it. Another thing which is very important is that whenever you go into options, in the advanced section, the maximum number of undos by default that's set to 20, and you need to change it to 8. Because 20 is like way too few undos to actually do real programming. And then, yeah, so then some other stuff which you want to worry about is the grid settings. So whenever you're adding stuff in PowerPoint, by default, the objects are going to like snap to each other. And if you like right click, you can go to the grid settings, and you can either turn that on or off. So you can like turn it on. Personally, I like to keep it off a lot of the time because I don't like the objects going where I don't want them to be. So once you've done that, now you can actually, like, you want to insert some type of like logic into your presentation. So how are we going to get like any type of logic at all? So the first thing that we can turn to is hyperlinks. So if we just right click on something, we can add a link, and we can put it inside of this document, and we can then make this interactive. Right, so now we have a very basic sort of quiz set up here. We can click, takes us to the slide, and then we can go over here, click, and that takes us to the slide. So this is very useful. This actually gives us a lot of sophistication, so we can create like all kinds of quizzes and stuff. And in fact, there's a formal way that we can characterize the computational power of this, which is a, quote, finite state automata. The computing power of a PowerPoint with hyperlinks is actually the exact same computing power as a theoretical DFA. So we can actually use a PowerPoint as a pretty good demonstration of what a DFA is. So if you're not familiar, a DFA, it's like sort of like a flowchart setup where you have a start state, which I guess I dropped a mark here, and then you can enter in some sequence of characters. So in this case, it's going to like accept a sequence that starts and ends with the same character. And then we can just be like an input, and it's going to accept that sequence. Or we can like go back to the beginning, and if it starts and ends in different characters, then it's going to reject that. So using this, we can like compute anything that only requires us to store a finite amount of memory. So you can do some interesting interactive stuff with this. So if you want to do like the keypad, so here we can like enter in some 4-digit code, 1, 2, 4, and that's incorrect. The correct code for this one is 7131. That's for GPI. So that's correct. And you can actually enter any code into this and it will accept it or reject it. So does anyone have a guess on how many slides you need for this?
Finite number.
Finite number, that's good, because PowerPoint only lets you have finite number, but like rough order of magnitude.
1,000?
So you actually only need to have 9.
Okay.
So it seems like you might need a lot, but you only need 9 because the only things you're remembering are how many digits have been entered and whether any of those digits are incorrect, right? So that's going to give you the 4 digits that you can enter and then whether it's correct or incorrect. And then we also have the star slide, so that's how you get the 9. So that's kind of neat that we can do this without too many slides, and that's because there's not very much memory involved. There are some limitations to this, though. It's not like a real application. Because we're using a slideshow editor, you have this annoying thing at the bottom, and anytime you like click or scroll, you like jump between slides. So this doesn't work for like an actual application, because most applications, when you click or scroll, they don't go through all of their possible state sets. So if we want to fix this problem, so that whenever we click, we don't go to the next slide automatically, we can go to the Transitions tab here, and it says Advanced Slide, and there's a checkbox for on mouse click, and a checkbox for after a certain period of time. Now, it's kind of interesting that these are checkboxes and not radio buttons, because it means that we can uncheck both of them. Right? So that makes sense. So we can just go here, now you click, hey, we can't jump between slides anymore. Wonderful, you have to use the hyperlinks. Now we still have this annoying toolbar at the bottom. Now, that makes sense, it's a slideshow editor, so of course it has like a slideshow toolbar. Now, would we expect Microsoft to like add a feature that lets us turn our PowerPoint into an application? Well, let's see. So if we go over here in Slideshow, we can go to Slideshow Setup, and there's this thing called Browse at a Kiosk, full screen. Well, what's a kiosk? A kiosk would be like you go to like some store and it has like some interactive display. So apparently Microsoft has a special mode for if you're going to use PowerPoint to make your interactive display at your store. And if you set it to that, then we can now notice that the toolbar is gone. If we scroll, we do not jump between slides. And in fact, the only thing that works is the escape key. So now we have something that works a little bit more like an application. Now, if we save this presentation, and we can close this, and then go back to the keypad. So if we open this, it's going to open like a PowerPoint, which is what we expect because it's a PowerPoint. But if you're going to send this to someone and you want them to think it's an application, this doesn't really work so well. So it would be nice if PowerPoint had a way that we could actually save this in some way that would launch automatically, like an actual executable. So if we change the file type, there's actually a special file type for this. So if you save it as a PowerPoint show.ppsx instead of pptx, then if you just jump to the application, double click it, it's now going to just launch automatically. So now we have something that looks fairly similar to an actual application. Still, one slight user experience problem is that it does not have a way to exit the application. So that's not a problem. We can just insert an X. And do we have the ability for our PowerPoint to tell itself to exit? We can set the color on that. Important to have a good design. So now we can go to insert, and we can go to insert and then insert action, and we can set this to hyperlink to end show, because that's a feature. And now we have an exit button. Great, so now we have something that looks like an application, behaves like an application. You can exit, you can enter, and you can't jump between slides like crazy. So that gives us the sort of basics of our like PowerPoint environment. Now we want to talk about sort of theoretically how powerful this computation is. So if we go back to here. So there are some limitations, right? So how many memory states, like how many memory cells can we simulate? If we're like simulating so many bits of RAM or whatever, the issue is that the number of bits of memory we can simulate is logarithmic with respect to the number of slides. So we actually need like a ton of slides to simulate like 10 bits of memory. We need like 2 to the 10 slides. So is there like some way that we can do better, that we can do more complicated calculations? The answer is yes. And the key thing is that PowerPoint has on-click animations. And those on-click animations, they're sort of like event-driven programming, are going to only trigger whenever you click on them, and they will change the state of the slide. So if we go over to our playground file, so we're going to do a little demo. So this is Portal themed, because I like Portal. So if we want to make a like little game here, you will have to, so in Portal, your goal is to get the character to the exit. So we can make it so that if you click on the exit, this character is going to disappear. And this character is going to appear. And we can set that to have a trigger on click of one of these items. So that's how we can actually set this to be triggered on some event. Now there is a little bit of a problem here, which is that all the items have very useless names, picture 2, picture 4, picture 5. So this teaches us a very important lesson in PowerPoint programming, which is that you have to comment your code. So if we open up the selection pane here, we can see a list of all the objects, and we can set this to be door. And now we can select these, and we can tell them to have a trigger on click of door. So now if we run this presentation, and actually, before I do this, I should set the slideshow to the UT command. So now we can click on the door, and the guy disappears, and we click again, and he appears. Not exactly what we want, but pretty close. And if we want to fix this, we can just change this one so that instead of it being set to be on click, we can set it to be with previous. And now whenever we click on the door, those two animations happen at the same time. Okay, so in Portal, you can't actually go through the door though until you open the door. So we might want to make it so that you have to like click on the button to open the door before you can get through the door. And this is a demonstration of how you do state management. So does anyone have an idea on how you do this? Make it so that the door is only interactive if you click on the button first. No ideas? That's all right. Oh, yeah.
Make a separate slide so when you click on the button, it goes to the slide that you can click on the door.
Yes, that would work, but we want to do this just with on-click animations. Yes?
Make another picture of the door which disappears when you click it, and then the one which you have to click to.
Yeah, exactly. Yep. So I actually have two door images here, and you can do the same thing. You do the opposite of that, which is what I'm going to do, which is I'm going to make this appear. So we make this door appear, and then we'll make that have a trigger. So quickly run over here, set this to be called button, and then we will have this door set to have a trigger of the button. Great. So now you click on this, and the door opens, we can go across, and if we run that again, so now we cannot click here until we click on the button. And then just to take this one step further, in Portal you actually have to pick up the cube and put it on the button before you can actually go through the door. You can't just like step on the button yourself, because then you're on the button and you can't step off of it without closing the door. So we can have this cube, and we can make it so that we can actually pick this up. And this is a good example, again, of state management, because picking up the cube is sort of like a Boolean, like either you have the cube or you don't. So we can make it so that we're going to add an effect so that this is going to disappear. And then we'll have this appear. And we want that to happen whenever you click on the cube. Just set that on click of the cube. And when this happens, we can now use the same strategy where once you have the cube, we want the button to become interactive. So we can just copy this, have a second one. This one is not going to be interactive, and then just make this disappear at the same time whenever the cube is clicked on. And we want these to be right on top of each other, so we can now use the alignment tools. The alignment tools are actually very useful in PowerPoint for getting things exactly where you want them to be. So we can run this, and right, so the button is not interactive. We can pick this up, and our button is interactive, and go across. And what we might really want to have happen is this cube is going to actually go onto the button whenever we click on the button. So we want this to appear here, and then we also want this guy to disappear whenever we click on the button. Again. So now you notice that something interesting happened. And this is one of those cases where you can kind of think about how PowerPoint is actually programmed, like how it's resolving some of the stuff that you've set up. Because it's actually a little bit underspecified when you set up a slide with animations, what the starting state should be. Because every element can either start on the slide or start off the slide. And what PowerPoint does is it just scans the animation pane linearly and checks to see if the first thing the item does is disappear or appear. If the first thing it does is disappear, it starts on the slide. If the first thing it does is appear, then it starts off the slide. Which makes sense if these are not on-click animations, but it does the same thing for on-click animations. It just looks at the arbitrary order that they've been arranged in. So in this particular case, both of these disappear before they appear, so they both start on the slide. We don't actually want this one to start on the slide, so we can go to animations, we can set this to disappear, and we can set it to do that immediately. And now, whoops, not from the beginning. So you can pick this up, and you can put it on a cube, or put it on a button, and then you jump across. Cool. Yeah, so that is sort of basic state management. Now you might wonder like how we can simulate like multiple bits of memory, like if we want to actually set it up to have like a sort of RAM equivalent. And this actually isn't too difficult. So we can have, this is like a demonstration where each of these buttons, so we can copy these. Each of these buttons is going to change what state we're in by making all of the circles disappear except for the one that's indicated. And what's really cool is that if we copy all of these, then PowerPoint's going to actually figure out the dependencies between these, and you'll get two separate modules that both operate independently, which is different from if you say just copy like the circles, then it doesn't have the click target, so it's just going to throw those animations right here at the top. But if you copy them with all as one group, then it's going to properly resolve them, and now we can simulate multiple bits of memory. So this is actually a very important part for the PowerPoint-Turing Machine, because we need to have a tape, and these are actually the memory modules from the PowerPoint-Turing Machine tape. So we can just click these buttons, and the way that these work is instead of having the bit that's set be the one that's visible, we have that be the only one that's invisible. That way the tape can be in front of a sort of like detector, and you can only click on the thing that is exposed. And we don't have to have like separate interactive buttons on every single tape cell. Cool. So are there any questions, by the way, so far? Awesome, great. So now we can look at the actual PowerPoint-Turing Machine and how it works. So this is what it looks like if you, in the expanded view. So we have the tape here, which is just a bunch of these memory cells stacked on top of each other. Then it also has, the memory cells have these arrows to move them. So whenever you click on this, it tells the tape to move over. And that's using a motion path animation. And then we have the so these detectors back here. So this is for actually reading from the tape. This is going to like correspond directly to where that hole is. And then this is for reading what state to go into. Then it has these blockers which ensure that the instructions happen in the correct order, that all the stages happen in the correct order. So like the first stage is reading, then we're going to have to like write the data, and then we have to move and like make sure that we're in the right state. And that's going to be controlled by this. And then this is going to determine which piece of data was read from the tape. So we can actually open that up now. This is going to get a little bit slow, possibly, because it has a lot of stuff. Oh. So let's go to this one. All right, so this is a binary counter. Actually, let's go to the palindrome recognizer. That's a little more interesting. Okay, so this is palindrome recognizer. So it's going to recognize palindromes of even length. So we start by actually setting the data on the tape, and we just click here, and that's making something disappear. So this orange thing is showing through, and is the thing which is going to actually read that data that it can tell the tape to move over. So we can do like 1, 0, 0, 1. And we can set that back to the beginning. And tell it to start running. So now it has those rectangles to make sure it does things in the correct order. So it's going to start with the read, then it's going to do the write, then it will tell it to move, and then it will tell it to go to the next state. And I do have to click to keep advancing this, but I'm not actually making any decisions when I'm clicking because everything's blocked except for one interactive zone. So if you set up like a macro that just clicks around the slide randomly, which you can do pretty successfully, then it will just advance automatically. Here, right, so this is a pretty basic Turing Machine program where we are kind of picking up the first bit and then checking it against the last one and deleting that. And then we just kind of do that repeatedly, right? So we now realize that we've reached the end of the string, and we can check to make sure this is a 1. It is a 1, so we are happy, and we just erase that. So you can keep on moving on. You can see that this is not like the most efficient programming language, but you could argue that it's very intuitive because you get to see all the steps of the calculation happening. Yeah, I'm not sure why whenever people use PowerPoints to present on Turing machines, they don't just use PowerPoint Turing machines. It seems like that would be a much better way to go. Right, so this is the last part. We can now erase this bit there. And then it realizes that it's reached the end at this point. And Great. All right, so that gets accepted. Cool. Yeah. So that is the PowerPoint Turing Machine, and like if you want to see the different stages of the calculation, right? If you're like clicking through it here, these would be these rectangles are going to like appear and disappear as we actually go through the evaluation. Right. So that's forcing that particular step to occur, etc. And then it's programmed using these punch cards. So these are the actual instructions, and that tells it what to do on every single state. So the whole indicates what it should do based on the data that it reads. So if it reads like a blank, then it uses the blank column, etc. Yeah. So are there any questions on this? Yeah.
Have you written a coin yet?
No. That would be interesting. So I'm not even sure what a coin would look like. I guess you'd have to have it output the binary code for the PowerPoint file. That seems like the most reasonable thing to do. And yeah, you could do that. You need it to have a lot of memory, but theoretically you could make it so that if you run it on an empty input, it's going to output the binary code. Oh, are people familiar with what a coin is? Okay, cool. You did that. Cool. Nice. Yeah, very cool. Anyway, yeah. So that is basically how the PowerPoint Turing Machine works. Are there any questions at this point? Yes.
Have you implemented PowerPoint in PowerPoint?
No, that's a question I get a lot though. But it does seem like it would be a good way to, like if you have PowerPoint 2007, which this works by the way on versions all the way back to 2007, and you want to have like PowerPoint 2013, then you just implement PowerPoint 2013 in PowerPoint and then run that in PowerPoint 2007 and then everything works.
I imagine that would be slightly harder than a coin.
Yeah, that would be slightly harder. The other problem is that you need to have a visual display, and making it have a visual display would mean you have to have a bunch of tiny colored rectangles that appear and disappear. It'd be kind of interesting because you need to have like an actual kind of like graphics adapter like coming out of the Turing machine where like whenever you hit certain buttons it makes the rectangles appear and disappear. You could do it. It would be a very low resolution screen though. Any other questions? Cool, yeah.
Could you write a program to compile to Microsoft?
To compile to PowerPoint. Yes, you could. In fact, someone tried to do this. I got a link from someone saying that they were trying to make a compiler that would compile into PowerPoint. They decided not to because it was too hard, but instead they made a PowerPoint CPU where they can take an already like compiled like assembly code and then they can have it use the PowerPoint to do the calculations. Where like there's some like Python code which like inserts all the data into the PowerPoint, then has it like add the numbers together, and then reads the data back out of the PowerPoint, and then does the next instruction and stuff like that. So that's kind of cool. Yeah. Any more questions? Because if not, I will go over some other PowerPoint tricks, which are quite interesting. Cool. Yeah, so some other fun PowerPoint things that you can do. So PowerPoint really demonstrates this principle of combining like features that are not meant to be combined and getting interesting results. So one thing, I'm going to close these, and I'm definitely going to close the Turing Machine, because that takes up a ton of memory. Great. So one really good example of this is PowerPoint has a neat transition, which is relatively new, called warp transition. And what it does is it interpolates between two slides. So it looks at the two slides, tries to find this sort of like edit distance between them, and then figures out what element to move to like transition one slide into the other. But this gives you like some interesting questions, like if we have two elements on this slide and one element on this slide, then what does PowerPoint do with that? It's like, oh, okay, it moves it to the closer item. But like, what if the color of this item is different? Like, is PowerPoint going to have a problem with that? It just moves it to the other item. Okay, that's fine, it evaded that. But if we change this color as well, like what's it going to do now? Oh, now it's going to move back to this item. So it's actually doing a sort of like a minimum edit distance calculation, right? So if it's actually closer to this one, now the edit distance is such that it prefers to go to this item. Okay, so that's like kind of fun. But like, what if we just get rid of both items and we get it like a circle, right? Like, what's it going to do with that? All right, so in this case, it just cheats. All right, that's disappointing, very disappointing. But this frequently happens with PowerPoint, where you try something, and then there's a little bit of disappointment, but then you try something else, some way of forcing it to do what you want it to do, and then something interesting happens. So let's add something like, let's see, what's a good example? We can go to a star. So we can add the star, and so the key thing is it looks like PowerPoint will only interpolate between two shapes if they're the same shape. And actually, just to demonstrate this, if we have like another circle here, and we actually stretch it and stuff. in this case, PowerPoint's going to actually be happy to interpolate between them. All right, so now we have the star. And the interesting thing about the star is it has this yellow control point, so we can change the shape. And that's going to be interesting. Like, is PowerPoint going to properly interpolate between those two different shapes? Let's see. Yes. So you might not have seen it available, but it's going to actually do that interpolation for us. All right, so that's interesting, because it means that PowerPoint's really just checking to see if the objects are the same type. And if they're the same type, it interpolates between them. And apparently, it has the ability to at least do some level of interpolation involving these yellow control points, or the path itself. So there's this item, a shape in PowerPoint, which is this freeform shape. So if we add a freeform shape, right, then we can add like another freeform shape that looks entirely different. Now, technically, though, they're both freeform shapes, right? So theoretically, PowerPoint ought to interpolate between both of them, right? Now, if you were like a sensible programmer given this task, what you'd probably say is, okay, freeform shapes can never interpolate between each other, and then we're done. Right? Like that would be what you do. But let's see what happens. Sure. Yeah, I guess that's what happens. So some like software developer at PowerPoint like was tasked with making the freeform shapes interpolate between each other, which is like a feature that probably nobody uses, but it's also like very difficult to make. But it's in there. So that's kind of interesting. Some other interesting things that we can try. So this is not going to look great, but we can do it. So here we have like an image. In PowerPoint, we can format this shape. We can tell its fill to be a picture fill. That's the image. Now, of course, first of all, this looks terrible. But anyway, the other thing about this is that how is it going to interpolate between these two items? Because now it has to interpolate not just the perimeter, but it also has like all this texture inside. And it's actually going to just do some kind of morph transformation that actually morphs, like flows the inside. So whoever had to develop this thing didn't just have to interpolate the perimeter, they had to interpolate all of the interior points just in case there's like an image set as the texture. So that's kind of funny. So what are some other things? Well, now that we have this knowledge that we can take freeform shapes and we can interpolate between them, what happens if we just have some like non-freeform shape, but PowerPoint has the very useful feature of taking shapes and merging them, right? So if we just have these two shapes and we tell them to merge, now what type of shape is this? Theoretically, this can't be a star, it can't be a square, so it's probably a freeform object, right? So what does that do? Yep. All right, so this now answers our question initially, which is if we just go back to the beginning, now we're making use of those 80 undos. If we just go back to the beginning here, where we have this circle and this rectangle, if we really want these to interpolate between each other, it's actually simple. We just union it with something that's already completely on top of it, and then we just union this with something that's already completely on top of it, and now theoretically, they're both converted into freeform shapes. So what happens? Oh, yeah, they just interpolate between each other. That's nice. So this is actually a useful effect. You can use it. So what are some other things that we can do here? How can we like combine features that probably were not meant to be combined? Well, we have some text. So here's some text. So what happens? How does this thing work with text? So if we have text, it's in this case. Let's get rid of this rectangle. All right. In this case, it just disappears. So, I mean, this makes sense because, first of all, this text is actually part of a rectangle itself. So these are different types of objects. This is a rectangle, that's a circle. If we have this circle and we put text on that, I mean, what we'd really expect it to do, if anything, is interpolate between the two circles, not the text content. That would be kind of weird if it did that. Yes, and I'm aware that that's a terrible design choice color. Anyway, so in this case, it just fades between them, which is disappointing. What if we have it just have different style text? Okay. So if the text is exactly the same, then it will interpolate between them. And actually, if we go to the morph transition effect options, it has objects, words, and characters. So actually, if we set this to say characters, and then we change this to like I, now it's going to actually interpolate on a character by character basis. So it took the H in hello, and it decided to reuse that H. Again, very useful, presentation stuff. If we delete that, now it's going to take the H from there. If we make this text black, it's going to be visible. Great, yeah, wonderful. Okay. So that's nice. We learned something. Well, actually, one thing that's really useful about this is if we set this back to objects and we have, say, two circles, and we really want like this circle. Let's change this one to be red, right? So in this case, and we can get rid of the text on all of these. So in this case, it's going to interpolate, right? It's going to use the blue one. If we wanted to use the red one instead, what do? Well, we just like put a piece of text, like an X on this, and they like put an X on this. And as long as it's the same exact tag, now it's going to be forced to interpolate that one instead, because it has to have the text match. So if we want to, we can just make these text tags invisible by going to text fill, no fill, because you can change the fill and the outline of the text, and there's no reason why it has to have either a fill or an outline. You can just say no fill, no outline. Right now we have invisible text. And then we can just do that over here as well. I mean, you can't see it anyway, but that will prevent it from becoming visible whenever it starts interpolating. And then we can do the morph, and now it's going to morph between them. And we now know that these two objects, you actually have to interpolate between those two things, because in this particular mode, it has to interpolate stuff between stuff with the same text. All right, so what are some other random things we can do? Well, we can insert some more text. And we can ask ourselves a question, which is, what happens if we take this? What happens if we take this text, the text box here, and we say do a shape union with some other shape? Actually, we'll just do the circle. Right. So what is the union of these two things? So we already know that if we take two random shapes, we can select them, and then we can tell it to compute the union. Right. And that gives us this new combined shape that, if we like look at the points it's made up of, that's actually some combined version. But what's going to happen if we compute the union of these two things? So like, the reasonable thing to happen here is that you get a union of a circle and a rectangle, right? That would be the boring thing. But PowerPoint is able to figure out that that's not really what you want here. And something very different happens, which is that it actually ends up tracing the text. So we now converted the text into a traced version of itself. This is very useful because it means that you can now distort the text and do all kinds of random stuff that is somewhat horrifying to any designer. But it's also useful because of something else which we learned. So if we do this, if we take this text, right, and we'll delete this circle because I don't want the circle. And then we can grab these. We can use a different thing, fragment, which is going to actually cut the text into pieces. So now each letter is its own separate object. So what happens if we add a little freeform object? Okay. So, well now, that freeform object is going to actually distort itself into that letter. So if we have a bunch of these things, and then we get a sort of genie effect where the text is going to just get automatically generated. All right, that's fun. Again, like, I don't know why these features are implemented, but they are. So if you want to trace your text into, like this is a problem which I have definitely encountered, like where I have text that I want to treat it as if it's a shape and not as if it's like actual characters. So you can use PowerPoint to do that. Oh, incidentally, if you're doing any of this type of stuff and you want to export these, PowerPoint does have an export to video feature. So you can use these if you want to get these like interpolation effects. You can just export it straight to video, and then you can use it in whatever thing you want. So what are some other interesting things we can do with this? Let's see. So another feature which PowerPoint has is 3D effects. So you might be familiar with these. These are the very dated-looking 3D effects that are sometimes used on presentations to make them more exciting, I guess. Now we can take these 3D effects and we can rotate these 3D objects as well. Right, so we actually have this 3D object. All right, now this is a little bit, the 3D effects are normally they don't play nice with a lot of other things because they're fairly complicated. So if you just like, if you take this object with a 3D effect on it and you try to like merge it with this object, it's going to just treat it as if it does not have the 3D effect, and then it's going to merge them. So it kind of works, but frequently these don't work well with other features. But what happens if we apply morph to them? Oh, so it actually does a 3D transformation on that. So this could be useful if you want to have some like 3D rotating thing, right? So you could use Blender or whatever 3D software you're supposed to use. You could also just use PowerPoint to like make this do some kind of crazy 3D rotation. Yep. Okay, so interesting. Also, speaking of 3D stuff, has anyone like tried to get a 3D asset for something, like for any type of project? I'm not sure if people. Okay, yeah, some people, yes. So I've always found it surprisingly difficult how like hard it is to get 3D assets. Like if you try to get a 3D asset, so we can just go to like Unity Asset Store. So if we want to like get some asset for something random, like fish. So like all the assets are actually like really expensive and somewhat terrible. I mean, some of them are good, but those are the expensive ones. And if we set it to only free assets, like these aren't even 3D, right? This is like 50 fish icons or whatever. So like getting 3D assets for stuff is actually surprisingly hard. Like getting 2D assets is pretty easy, probably because 2D assets are way easier to make than 3D assets. But if you go to PowerPoint, it has this insert, it says 3D models. So if we do insert 3D models, we can search for model. And we get a lot of 3D models. They're all significantly better than the ones in the Unity Asset Store. So that's kind of funny. Actually, let's insert one of these.
21st century, baby.
So if you want 3D assets for your project, you probably should not go to the Unity Asset Store or any other asset store because they're normally pretty expensive. You can just go into PowerPoint and then go to Insert 3D Models, and you can get a very high-resolution 3D model. Like, I was actually very surprised with the quality of these models because it actually has like good lighting effects and everything. I'm also like surprised with the quality of the renderer because it also will like capture reflections on like reflective objects and stuff. Now there is one problem, which is that it's a PowerPoint file and not a 3D file, right? So if we save this PowerPoint file somewhere, let's just save that to the desktop. We can call that 3D, right? So we now have this PowerPoint file over here. Now you might know that PowerPoint files are actually just zip files. So if we just rename this to be a zip file, we can now look at the contents of the PowerPoint file, which I already have that because I already tried that before. 3D. Very good naming conventions. I'm and oh, can't be where is it? Yeah, I should have read that. Anyway, 3D and I actually need to have a dot. 3. Anyway, so now we can open this, and inside of it we can see the like what a PowerPoint file looks like on the inside. So we can go to PowerPoint, Media, and oh, there's something called model.glb. This is actually a 3D asset file. So if we copy this out, we now have a very nice 3D asset file, which can be opened in our 3D model viewer. That takes a while to open. But in any case, yeah, there we go. So this is an actual 3D asset file. Now you have to convert it to use it in Unity. But if you want to do any project for 3D assets, like apparently PowerPoint has a better asset store than most other things. Yeah.
So what's the licensing on this?
I do not know. That's a good question. You can probably look at that. However, I wouldn't be surprised if the licensing is pretty good because given that you're able to like include it in a PowerPoint presentation, most of the I think that they probably have it set to be some type of royalty-free license, but I'm not sure on that. So you should probably check. Yeah. So let's see. What are some other random experiments that we can run? So going back to morph transition because that's very fun. If we insert like an image. Like, what happens if we give this image, say, a shadow? And then, let's do this shadow. Not great because the width is much larger than the height. Anyway. And then maybe we crop this as well. So the question is, if we crop this image, then what happens whenever we decide to morph between it? So if we go to transitions and set this morph. So this is like interesting because what I would probably expect it to do is reshape the rectangle into the other rectangle while doing a crossfade between them, because that's what it does for textures on other objects. But it's actually going to do a crop. So it actually does a sort of like crop and zoom effect, which can be very useful if you want to like zoom in on some type of detail. And I'm not sure exactly how this works because it has to know that this image is the same image as the other image. And it has to know where that's positioned. But it must be knowing that they both point to the same image asset, so it decides to just zoom, etc. Yeah?
Do you know if this doesn't work if you have like 2 copies of the same image?
2 copies of the same image, that is a good question. The best way to test that would probably be to take one image and put it straight into PowerPoint and take the other one and paste it through Paint. So if we just take this and we put it in. Now I'm not sure if PowerPoint's going to do some like like detection to see if these are actually the same image. There we go. So this is actually the exact same size now. And then if we put this here, and now we try and crop it. Yeah, so you can discover a lot about how PowerPoint works inside by doing some of these weird edge case things, because we can like figure out what the internal representation of these images probably is based on if this works, which it does. Right, that's surprising. I guess PowerPoint did some type of image diff on that. I don't know. That's weird. All right, this requires more investigation. All right, what is going on with this? So we do this here, right? And now we crop it. Like, come on, this is clearly a different image. I hope, I think. Otherwise, I'm getting a little concerned. Uh-oh. What's going on here? Is it doing an actual pixel-based image diff to figure out how to align the two images? Because that's what it looks like. Okay. Yeah, it looks like it's actually somehow doing a pixel-based image. What happens if we resize it? Like, if we tell it to do like some kind of resize to something like 70 pixel or 70%, right? So now this is going to, we want to resize the entire thing. This should theoretically force it to, because these pixels are now all completely different. So what happens if we do this? All right, so in that case, I mean, that's just the same thing, but if we crop it over here. What? Okay, so somewhere in there, there's also some like image comparison algorithm. Like at least that's the only explanation I have right now, is that it's running some image comparison algorithm. That, or it's just because this one's cropped and this one isn't. I don't know. Yeah, maybe one thing is that we did make them both the same size. So it could be, like that might actually be it. That it might be because it just knows. Yeah, maybe it will do a crossfade now if it's actually different dimensions. That's my guess.
I would do it.
Okay, well, that's still not what I was expecting, because I mean, it did a crossfade, but it got rid of this object entirely. Like, I was thinking it might slide it over and crossfade, but that means that this has somehow failed its, like, comparison test, whatever that is. What if it's, like, 1 pixel off? All right, so you can see that you can spend a lot of time, you can waste a lot of time by playing with PowerPoint trying to figure out how on earth some of these things work. Okay, that's close enough, I guess. What? Okay, that's concerning. I did not know that happens, that it has some kind of image comparison in there. Does anyone have any other suggestions for experiments to try? Yes, other fun things that you can do is, you just add some text. And if we have like an image now. So the cool thing about the merge tool is that you'd think it would only work for shapes, but it actually works for text and for images. So if we like take these two objects and we tell it to do an intersection, then we're going to actually get a, that's not very visible, but we're going to actually, here I can just change the background. Right, so we get the text that cuts out that image. So another useful effect if you want that for something. Yes, this is great design here. So I do actually use PowerPoint for design though. Actually, I can show you our puzzle hunt website. So previous hunts are not that one. That one is SIO themed. But this, yeah, so like this is something which some of our members did in PowerPoint. So you can use PowerPoint for pretty sophisticated design stuff. Yeah, cool. Any more experiments?
What about between 3D objects?
Between 3D objects. So I definitely would be shocked if it interpolated the mesh. It definitely does not do that. Okay. At least I'm pretty sure, because I didn't think it did the image diffing either. But if you do it between two 3D objects that are the same object, then it actually does a very good job of it. So if we add this, it takes a while to download because these assets are actually like very large. Like I was again surprised by like how high resolution these are. like why does PowerPoint come with high resolution fish models? Actually, my hypothesis that has something to do with HoloLens. Like Microsoft probably like got a bunch of 3D assets for HoloLens, and they're like, what else can we do with these? Let's put them in PowerPoint. Yeah, so let's transitions. Yep, so it does that. Oh, right, another very important thing which I do have to show you, we have like 3 minutes, but that's all right, that's still enough time for this, is slide zoom. So if you have a PowerPoint presentation and you want to make a summary slide, you can do that. So let's just add, like this is a slide all about rectangles, and this is a slide all about circles. And then this is our summary slide. We can drag a copy of the slide onto this, and it makes a link, and it's a sort of dynamic link in that if we move the item, it's going to actually move here. And let's just change the background really fast so you can see. Anyway, so we can do this here. Right, and again, if we change this object, like change this to be a color or something, and it changes. And if we click on it, it's going to actually do the zoom into it. Right?
Wait,
So,
I have a question.
oh yes, good. You might be thinking the right question.
What if you then make a copy of that slide?
Yeah, so that's like the first thing you would think to yourself, which is like, if you're a software developer and someone's like, make this thing, you're like, okay, but no cyclic dependencies, right? No cyclic dependencies. So what happens if we introduce a cyclic dependency?
Uh-oh.
Let's make this look a little nicer here. So if we just delete these. Alright, that's nice. That's what it does if it has a broken line, apparently. So can we use this to make some cool fractal images? The answer is yes, we can. So we can just like take some, stick this in the corner here. All right, so this is looking pretty good. There is a problem though, which is that it has this white background because it's a slide, which is something that we would expect. If only there was some way to get rid of that. Oh, there's a way to get rid of that. So yeah, there's a built-in option for getting rid of that background in case you want to make fractals. Like that's the only reason I can imagine that's yeah, so we can just. In fact, I have a reference file which has some cool fractals in it. Okay. You can make a lot of fractals. Here's our. Here we have a spring C triangle fractal. So we have to wait for it to do the propagation, because it's just like doing this over and over again. It realizes, uh-oh, the slide changed. Have to redo these thumbnails, and then it just keeps doing that. Now you do have to do an edit though to tell it to like do it again, because it does have a limit on how many times it will do that. And eventually this is going to fade out. That's because the spring C triangle has like fractal dimension that's less than 2, so it's going to fade out. But this one doesn't. So we can click here. And it's going to actually zoom in, right? Because it's going to do the zoom animation because that's what it does whenever you click on the thumbnail. Now, for some reason, it also decides to keep the other stuff around the edges here. And that's because we chose to make the thumbnail have a transparent background, and it decides to retain the copy of the slide that you came from as the background, just to make it look more fractally, I guess. Then we can make fractals with our fractals. So we can do all kinds of stuff here. Zoom into these. We can, let's see, yeah, we can do that. This is not quite as interesting. We can also do like a dragon curve fractal. So this is actually only two thumbnails here. So if we just cover this, right, it's not going to propagate that blue square down on all the thumbnails. You can see that there are only 2 thumbnails here, but now it's going to keep on propagating, and there are a few fixed points in this, and that actually gives you that dragon curve shape. If I edit it a few more times, it's going to propagate further. To make this work, by the way, you do have to get these in the perfect location, which you can do by calculating where they should go and then measuring them by adding rectangles and using snapping and control, like typing the numbers. So if you want to do that, yeah, that looks great. We can also do 3D. So this is actually just a 2D fractal still. It's just that by placing the object's offset, it's going to look like it has depth to it. You can use glow effects. So that's what this green is from, is that I've added a glow effect to both of these images. So if we take that glow effect off, then it's not going to have the leaves anymore. Those are going to fade out. But if you put that back on, different color. Right, now it's going to have that glow effect on top. Yeah. Oh, and one more really fast thing, which is an actual presentation feature, which is fairly new, which I was very impressed by. which is you can have PowerPoint automatically design your slides for you. Now this is actually used for making presentations, so I don't find it nearly as interesting as these other features. But we can do like programming, right? And then on. So we can tell it to design a slide, and we can tell it, all right, great. We can also now give it PowerPoint. So, alright, so just like some random bullet points that might appear on presentation.
What?
Yeah. So what it does is it actually figures out what icons are by related to the content of the bullet points, which I was pretty impressed by, and it will give you alternative suggestions as well. For the icons. Yeah. So my little message here is that PowerPoint does a lot of stuff that you probably didn't know that it does, and hopefully a lot of this stuff is not useful for practical purposes. A lot of the stuff actually is. If you randomly decide that you need to convert between image formats or something, then PowerPoint might actually be the easiest tool to do it in. So, yep, that's the presentation.
Incredibly put Microsoft PowerPoint on his resume. That's it for us. Thank you so much for coming.
Thanks for coming.